yesterday that we are busy now doing forces. So today I want us to look at what is the lesson all about today. So today's lesson is about the following. Okay, yes. So today's lesson, you'll look at field forces. We'll focus on gravitational force, weight, mass, and we'll start with magnetic force. But before we can continue with today's lesson, let us do the corrections from yesterday as homework. So this is what you were given yesterday. They said to you, find the acceleration produced by a force of 5 newtons acting on a mass of 10 kg. So now we already are aware of what you call of our we are already aware of our equation. Are we clear on that one? The equation that we are using, we said we are going to use F equals M multiplied by A. Anyone who wants to assist me on working out this one, raise up your hand. If you want to actually assist me in doing this this small what homework, do I have anyone who wants to assist me? Find the acceleration produced by a force of 5 newtons acting on a mass of 10 kg. And then yesterday I said to you, I explained to you that F, obviously it's for force, and then mass is for M it's for mass, and A is for acceleration. So if there's no one who is willing to actually assist me, let me do this one, maybe on the next one.
Sir,
Yes.
I raised up my hand. So because of me finding acceleration, I divided, which gave me 2.
Okay, let's say I see you, Amra. We're gonna do B with you, Amra. And then we said we need to first do what? We've got this formula, F is equals to M multiplied by A, but then now we are given the force of how many? We are given the force of 5 newtons. Then it's equals to, what is the mass? Is
the mass, which is
10 kg.
Is 10 kg, yes. And then we multiply by A.
A.
So we know that multiplication sign, we don't actually need to always put it there. We can do this. We can put A and A like that. So we've got 10 kga. So what are we going to do? We are going to divide by, we are not looking, we are looking for acceleration. So we've got 10A this side. Let me do it like that so that you can see it. We'll say 5 is equals to 10A. 10A. Then you divide by what? You divide by 10 both sides. Are we clear on that one? Are we clear? So if you divide by 5 both sides, what is going to be left? It's going to, because we are not looking for 10A, but we are looking for acceleration. Therefore, you are going to say 5 newtons is equal to 10 kga. So we divide by 10 kga, so that 10 kg will cancel 10 kg. And then on the other side, we will have space. We'll have 5 over 10. And then we have 5 over 10, which is equals to A, which is equals to 5 over 10 is equals to A. And then we can conclude that our acceleration is, backspace, enter, our acceleration equals
0.5.
0.5 meters per second squared. Yes, meters per second. Anyone who got this?
So may I please ask something?
Yes.
Why do you divide with the number that has a variable?
No, it's not the variable of a number. That one, isn't it, that 10 multiplied by A is going to be 10A, but we are not looking for 10A because now we need that variable, which is A, for acceleration. Remember that 10 is for mass. So mass multiplied by a acceleration, we get the 10a. That's why I wrote 10a here. I said 5 is equal to 10a. Then we are not looking for 10a, we want a. So we are going to divide by 10 both sides so that we get the answer for acceleration.
Oh, thank you, sir.
Yes. Amra, are you? Let us do B now. For a girl weighing 25 kg stands on the floor, and she exerts as she's standing on the floor. Now she applies a force of a downward force of 250 newtons on the floor. What force does the floor exert on her? So you are given that a girl is weighing 25 kg and she stands on the floor. She exerts a force, a downward force of 250 newtons on the floor. What force does the floor exert on her? Amra, are you there? You had raised your hand earlier on. So we are looking for force. So F here. What force is she actually now exerting this girl on the floor? Anyone, any volunteer for the answer? What did you write for a girl weighing 25 kg and she is standing on the floor? She exerts a downward force of 250 newtons on the floor. What force does this lady or this girl exert? What force does the floor, yes, exert on her now? What did you get? Anyone? What did you write, guys? What did you write for this one, for B?
So I wrote 10 newtons, but I'm not sure.
10 newtons. How did you get 10 newtons?
I divided 250 newtons by 25 kg.
No, it's not the correct answer, Nkabiti. Who else? What else did you write? Anyone else? James, you are in class.
So
Jason, I
isn't
saw
like
you.
laws.
Huh?
Isn't like laws to learn.
But what did you get? What answer did you write?
I got 10 newtons.
No, it's not 10 newtons. Amra, where's Amra? Is she around? Who else is there to give us an answer for this one before I give an answer? Anyone? Okay, let me give you an answer, grade 9. The correct answer there, because she exerts a downward force of 250 newtons on the floor, and now the force that the floor is exerting on her is 250 newtons. One would ask how, why Mr. Mbata is she exerting 250 newtons? Remember, when we talk about balanced forces, there won't be any reaction. So now she is applying 250 newtons on the floor, and then the floor is actually, the reason here is balanced forces. Balanced forces. Remember, we spoke about balanced forces earlier. So here they gave you just the weight of the lady there, and then they wanted to actually see if you are still aware of your laws. If you are still aware of your laws. So she applies 250, the floor is applying also 250 newtons on the girl. Anyone or with question there? Remember, you can go back and read on your balanced forces. If you're looking at your balanced forces there, we said forces act in pairs. Remember, we said forces act in pairs. So balanced forces say two forces that have no visible effect because they are exactly equal and opposite. So if she's applying downward force of 250 newtons on the floor, and the floor is also applying an upward force of 250 newtons. I'm hoping my grade 9s are clear on that one. And then they say to you, name the physical quantity which makes it easier to accelerate a small car than a larger car. So when you are looking at F is equal to M multiplied by A, and then it's mass multiplied by acceleration. So you already know that force is not obviously visible. So now what else is, which we're already looking for, what the visible effect here? So mass. The lighter the car, the faster it will obviously move. The bigger the car, the lesser. If you're looking at the bus and the small car, the bus is always slower than the small car. I'm hoping my grade 9s are following. Let us do the last two parts. So here I repeated the question. I only saw that when I was doing the corrections. Find the acceleration produced by a force of 5 newtons acting on a mass of 10 kg. So we already know the answer here. I showed you the steps. So it will be F is equals to force is equals to mass multiplied by, we can always do this like that, mass multiplied by acceleration, which is equals to 0.5 meters per second. Then here they say to you, grade 9s, what is the force which produces an acceleration of 1 meters per second in a body of 1 kg? So they are looking for a force. F is equals to mass multiplied by acceleration. And then they say to you, what is the force? So we are looking for the force. So we can say is equals to, the mass there is 1 kg, 1 kg, and then they said multiply by 1 meter, 1 acceleration there is 1 meters per second squared, 1 m per second squared, obviously, and then it's equals to 1 newton. 1 newton. Anyone? Are you following grade 9? So here we're just doing the substitution. We're looking for force, and then we know that the unit for force is actually what you call Newton. Any questions before we start with our today's lesson, grade 9? Any questions? So there are no questions. There are no questions. Thank you. I hope you understand how to calculate. So today, let us look at field forces, grade 9s. So when we are looking at field forces, we know that field forces, there is no contact force. So there is no contact force. If you're talking about no contact for a non-contact force, so we are talking about force that is exerted over a distance, and it can also be called a field force. So non-contact forces, they are also known as field forces. So, and then we also need to know that field forces act over a distance. So there is a distance in between, and then that's why you're saying it's a field force. It's a field force. So two bodies exert field forces on each other without touching each other. So they are reacting in a distance and they do not touch each other. That's why you call them field forces. So types of field forces, we've got 3, grade 9s. We've got 3 types of field forces. Remember yesterday we said we also have 3 types of we've got 3 types of contact forces. We said the types of contact forces that we have, it's tension, compression, and friction. Those are contact forces. Field forces are non-contact forces. So yesterday we did contact forces and we did 3 types: friction, compression, and tension. Today we are doing non-contact forces, and we're also saying we've got 3 types, and these types are as follows: gravitational force, magnetic force, and electric force. Gravitational force, magnetic force, and electric force, and they are all known as non-contact forces or field forces. Are we clear, grade 9s? Okay, let us now look into gravitational force. So when we're talking about a gravitational force, grade 9, remember yesterday we spoke that the Earth has a force of gravity or a gravitational force, which obviously says whatever goes up must come down. That's a force of gravity. Then now we're saying this gravitational force is a pulling force that bodies exert on each other over a distance due to their mass. Grade 9s, for you to understand gravitational force, please bear in mind the type of balance force. We said there won't be any effect if balanced forces are acting on each other, right? So let's say if 5 Newton is acting on a 5 Newton, obviously there won't be any difference now. There won't be any effect. You won't see any change because they are equal in forces. Are we clear on that one? So a gravitational force is a pulling force that bodies exert on each other over a distance due to their mass. Remember in grade 8 and 7 going down that you were taught that matter is something that has mass and takes up space. So matter is something that has mass and takes up space. So all the objects you can think of have mass. So then now, if they've got mass, then they will be taking up a space. They will be taking up space. So they are matter. Then I'm here now. Any object in the universe will therefore exert a force of attraction on any other object. Any object in the universe will therefore exert a force of attraction on any other object. And then gravitational force acts in a gravitational field. A gravitational force acts in a gravitational field. That's why we say these are field forces. And then they are acting in a distance. So there must be a distance for field forces to actually take up space. You exert a tiny gravitational force on all the people and objects in the classroom or in wherever you are. You are exerting a gravitational force in a table, in your walls, and everything there. It's a tiny one, so it's small. So that means, and every other object around you, it is also exerting the tiny gravitational force on you. Remember that this force is balanced because you are exerting the same equal force but different. The wall is pulling you and you're also pulling the wall back to you with that tiny force, hence there is no effect. In our solar system, the sun exerts a gravitational force on all the planets and each of them exerts a gravitational force on the sun. That is one of the reasons why the planets stay in an orbit around the sun. So the sun is exerting a certain force on Earth, and the Earth is also exerting a certain, it's equal but opposite. So the sun is pulling the Earth and the Earth is pulling the sun tiny bit, but that's why they are in an orbit. So that means all the planets are also doing the very same thing. So the balance forces, remember grade 9, you do not see any difference. So gravitational force works in pairs, grade 9. They work in pairs. That's why you exert and it also exerts back at you. You already know that forces work in pairs. And this is also true of gravitational force. So as I've been explaining about the gravitational force, that you are exerting a certain force and that it's also exerting equal but opposite. So we say those are balanced forces. There won't be any effect. You exert a gravitational force on the person sitting next to you, and that person exerts or applies exactly the same size of gravitational force on you, but in the opposite direction. Therefore, you will not see that effect. Are we clear, grade 9s? Remember to stop me if I'm moving a bit too fast. So planet Earth exerts the gravitational force on you, and you exert a gravitational force on of the exactly same size. But if you jump from a plane, the gravitational force is big enough to make you move towards the Earth. So that's why when you're jumping, you come back immediately or almost immediately, because now when you move away from Earth or from the ground, so now that means the Earth will have more force on you. You'll jump down from up to down. It's because now the amount of force when you're jumping off from Earth, it becomes more. But it is not big enough to make Earth move towards you. So when you go up, your force is not much of a force to actually pull Earth to come to you, but the Earth's force is bigger for it to pull you to come down. For example, if you take a stone and then you throw it up, you will see the difference. So that means the Earth will have more gravitational force to pull the stone down, but the stone will have less gravitational force to pull the Earth up. I hope I'm making sense. So let us look at the demonstration of gravitational force as a part of our classwork. So you will need a ball of paper, a pen, leaf, eraser, and a toy car. So now you will just take any paper and then you make it what you call a ball, and then you have a pen, you have a toy car, you have an eraser, and then what else do I have? Oh, you have a leaf. Yes. So now you have to compare the sizes of them. And so throw the ball of paper up in the air and you write down your observation. So the ball of paper will come back very fast. If you throw it up, it comes back very fast. And it will not go that much high. Then you will have to write those things down. And then compare the sizes of the force of Earth on the ball of paper with the force of the ball of paper on Earth. So now, what is the force of paper on Earth? So we all know the force of paper on Earth will be less because the Earth will not move towards the paper, but the paper will always come back towards the Earth. Therefore, that means the gravitational force of Earth on paper is high, and the gravitational force of paper on Earth is low. Then let's continue to see another one when you're looking at these sizes of these things. So explain why the ball of paper is moving towards Earth while Earth is not moving towards the ball of paper. So now I've explained to you, the ball of paper is moving towards Earth because the force of gravity of Earth is higher or is bigger than that of paper on Earth. Do you understand? Therefore, paper will always move towards Earth because the gravitational force of Earth is higher than that of paper. Are we clear? So repeat step 1 to 3 with a pen, leaf, eraser, and a toy car. Write down one final observation that is the same for all the objects. So the same, what is same for all these objects is that the force of gravity of Earth is always higher than that of the object on Earth. Are we clear, grade 9s? Any questions? I'm willing to take questions. Any questions so far? Do you understand how force work? Do you understand how force work? Okay, thank you.
Yes, sir.
Thank you. Let's continue, grade 9s. What's happening now? So the size of gravitational force, let's look at the size of gravitational force. Yesterday I introduced you to this very, very brilliant guy called Sir Isaac Newton. So Sir Isaac Newton formulated a law that describes the gravitational force that two objects exert on each other. He discovered that the gravitational force that two objects exert on each other becomes smaller if we move the objects further apart. Are we clear? If we move the objects further apart, we are separating these objects, then what's going to happen is that the gravitational force that they actually exert on each other, it becomes less. So you all know that with your friends, when you're at school, your bond is very, very tight. You know, you are tight, you are besties and everything. But the minute COVID-19 started, what happened? You stayed at home and your friends stayed at their places, and then you are no longer that tight. You know, you chat when you've got time, and but when you're at school, you would chat all the time. So Sir Isaac Newton was very what you call practical. When two things are closer together, the gravitational force that exists between them is very high. But when they go further apart, it will obviously be different. So, did you know the name of the law that Sir Isaac Newton's formulated is known as Newton's law of universal gravitation? This law, Newton's law of universal gravitation, you will deal with it until you finish your doctorate in physics. It will never change. It's Newton's law of universal gravitation. I hope one day we'll have your law as well. So Newton also noticed that the more mass two objects have, the larger the gravitational force that they exert on each other. The more mass two objects have, the larger the gravitational force that they exert on each other. So the gravitational force that you and a chair exert on each other is much smaller than the gravitational force that you and a minibus exert on each other. Are we clear? So the chair obviously is not as it doesn't have much weight as you, so that's why it will be smaller. But you and a minibus, you both have a stronger weight or bigger weight, so you will have a higher gravitational force. And then let us look at this. It's a classwork. If Tulisile answers her cell phone, what happens to the distance between her and the cell phone, as compared to the distance between them when the cell phone is placed on the table? What happens to the distance? So the distance, obviously, the cell phone, when she is picking up a phone, the distance will be very closer. So it becomes very close than when it was a bit far on the table. So 2A is asking now, is the gravitational force between Tuli and her cell phone smaller or larger when it is on the table? So the gravitational of Tuli and the phone, when the phone is on the table, is obviously weak because of the distance. Remember that Newton, or Sir Isaac Newton, state that if the objects are further apart, then the gravitational force between these two objects will be actually weak. But once they are closer, the gravitational force is actually bigger because now of the distance. Then, so they say 2A, is the gravitational force between Tuli and a cell phone smaller or larger when it is on the table? The answer is smaller. Explain your answer in 2A because of the distance. The further the objects are apart, the smaller the gravitational force between them. And let's continue grade 9s. Jerome picks his baby sister up from her cot and carries her. So where is the distance smaller between Jerome and his baby sister? Is it when she was on the when the baby sister is in the cot, or when the baby sister is in Jerome's hands? So when obviously Jerome picks his baby sister up, then the distance is smaller between them. But when she is in the cot, the distance is larger. I hope you understand. So B says, where is the gravitational force greater? The gravitational force is greater when obviously the sister is in Jerome's hand or arms. Yes. Let us continue grade 9. I hope you understand. These are types of questions that you should expect when you go back to school or when you're writing your exams. These are types of exams that exams questions. Let us look at mass and weight grade 9s. A measure of the amount of matter that a body is made of, so that will be your mass. A measure of the amount of matter that a body is made of. And then weight, the earth exerts a gravitational force of you. This force is so strong that you cannot jump very high or cannot float in the air. So that will be because of weight, grade 9s. Are we clear? And please, grade 9, look at the difference between mass and weight. Do not confuse the two. I will explain to you as we proceed why I'm saying that. You may have seen a picture of astronauts on the moon showing them able to jump very high and almost float over a small distance. Therefore, the moon has a smaller mass than Earth. That's why people, we know, when we were watching the movies and then we'll see astronauts in the movies, they're able to float and all that because in the moon. So that means moon has a smaller mass than Earth. So there's less gravitational force on the moon than it is on Earth. The difference between weight and mass. Any celestial body such as moon or planet exerts a gravitational force on an object on its surface. This is called the object's weight. As for all forces, weight is measured in newtons. Are we clear? Weight is measured in newtons. So, and then mass is measured in kilograms. You have picked that up already because we've been doing this. Let's continue grade 9. Your weight on Earth is different from what it will be on the moon or on Mars or any other planet. Your weight on Earth is different from what it will be on the moon or on Mars. This is because the gravitational force that you and another body exert on each other depends on both your masses, grade 9. Are we clear? I've got an example here. Okay, yes, there is it. So they say a body's mass is a measure of the amount of matter that is made of. So in everyday life, mass is measured in gram or kilograms. If your mass is 65 kg on Earth, it will be 65 kg on the moon or any other planet. Your mass, not your weight. Are we clear? Your weight differs from planet to planet, but your mass is consistent. Your weight will be different elsewhere in space, but your mass stays the same. On Earth, an object weight is about 9.8 times its mass in kilograms. So on Earth, an object's weight is about 9.8 times its mass in kilograms. On the moon, an object's weight is about 1.63 times its mass in kilograms. So you can already see that if you weigh more on Earth, you will weigh less on the moon. So, for example, your weight on Earth, we said you are 65 kilograms, you multiply by 9.8, and then you're getting 637 newtons. Your weight on the moon, you get 65, which is 65 kilograms, multiplied by 1.63, or that is obviously the force on the moon, and then you're getting 106 Newton. We use a special instrument called spring balances or force meters to measure the weight of an object on Earth. I'm hoping that you're taking those 9.8 and 1.6 because I would say please calculate your mass on the moon. So if I'm saying please calculate your mass on the moon and then I give you your weight on Earth, you will just take whatever weight that I gave you on Earth and then you multiply by 1.63 and then you obviously have to give it to me in newtons. Grade 9s, did you know it is scientifically wrong to say that someone has a weight of 50 kg? A person has a mass of 50 kg. A person has a mass of 50 kg, not the weight of 50 kg. Are we clear on that one? Yes, you're in grade 9 and you've been taught by Mr. Mbata natural science. Don't embarrass him next time. Yes, thank you very much. Let us look at the homework for today, grade 9s. Please write it down. Here's the homework. Who discovered the law of universal gravitation? A. Newton, B. Einstein, C. Kepler, or D. Planck? Number 2, what is a gravitational force? Is it A, a repulsive force between any two objects with mass, or a force of attraction between two objects with mass? C, a force between any two objects, whether or not they have mass or energy. A repulsive force between any two objects with mass, a force of attraction between two objects with mass, a force between any two objects. Please do the homework. I'm sure you are done writing now. The homework continues. State whether the following statements are true or false or partly true. A, friction always slows things down. Is it true, false, or partly true? B, cars. So you need to state whether the statements are true, false, or partly true. So A, friction always slows things down. B, cars need friction to keep moving. C, you could walk without friction. You could walk without friction. Matches light because of friction. So a match, a match. So does it light because of friction? Is it true or false or partly true? E, you could not pick up a cup of tea without friction. You could not pick up a cup of tea without friction. F, friction is useful in playgrounds. Friction is useful in playgrounds. G, pencils do not need friction to write. Pencils do not need friction to write. H, there is no friction when you are roller skating. There is no friction when you are roller skating. I, shoelaces stay tied up because of friction. Shoelaces stay tied up because of friction. And the last one is, snow increases the friction between your shoes and the ground. Snow increases the friction between your shoes and the ground. Do I have any questions, grade 9? Do I have any questions? Any questions?
Sir,
Yes, Ungabetsi.
for the equations, do the mass stay the same?
The mass, no, it doesn't. You are always given a mass, or sometimes you have to calculate the mass. So you'll use the first trick that I showed you when you are, obviously, you will divide. You can always, before you can do your substitution, you can always say F is equals to MA. And then if they say you are required to actually find the mass, so you know that you will do what? You will divide by A both sides. And then you know that, okay, A will cancel A on the right hand side, and then you say M is equals to F over A, and then you do the substitution, and then you get your answer.
Thank you, sir.
You're welcome. Any other questions, grade 9? Any other question? Did you all get your homework? I hope you all did get your homework, and if you actually meet any challenges and I'm not here, you can go to that link. There is a very helpful link with Isfasol Inzalo books for grade 9, and you can actually check for your problem there. I'm hoping that that source will be able to actually assist you. And then next lesson, we'll be calculating the magnetic force, the force of attraction, the force of repulsion. We'll also look at the like poles and the unlike poles when we look at the electrostatic force. Have a great Thursday afternoon. I see you tomorrow. We can keep the conversation at Africa Teen Geeks or at Africa Teen Geeks on Twitter, at Aziora, at BDESA, or at Sasol Foundation, at Sasol SA, or you can hashtag us at STEM Champions. And you also have my social media handles. I thank you for joining me today. Have a great day. Bye, everyone.
Bye,
Bye. Bye. Bye.
Bye.
Bye. Bye, Nkosi.
Bye, everyone.
Bye.
Bye.